Hello everyone, welcome to another video. If you are new to this channel, please remember to subscribe to this channel, like, comment, and share. Now what we're going to look on in this video is how we solve a pair of simultaneous equation by using inverse. Alright, now let me just refresh your memory. If you have a matrix, which is matrix A equal to A, B, C, D, then A inverse is equal to 1 over AD minus BC times the matrix D minus B minus C, A. Now what is this saying? The inverse of a matrix is just basically 1 over the determinant times the adjoint of the matrix, right? And you basically obtain the adjoint of the matrix by switching the term in the leading diagonal. So here, the original was AD. Over here to get the adjoint, I switch it to DA, and then you change the signs of the other term. So this was positive B, it becomes minus B. This was positive C, it becomes minus C. Right? Now you must also bear in mind that A inverse times A equal I. Right? Also you must bear in mind that I is equal to the identity matrix, which is 1, 0, 0, 1. Now remember that the identity matrix function just like the number 1. For example, if you multiply 1 times anything, it gives you back itself, right? So that's the function of the identity matrix here. Now, in order to solve a simultaneous equation, we must always write the given system of equation in the form of AX equal B, right? So here I have 3 examples, and I'm going to work example 1 first. So example 1, we have 2x plus 5y equals 0, and 3x plus 4y equals 7. So the first thing I would need to do is to write this equation in the form AX equal B. How do you do that? All you're going to do is to take the coefficient of each term to create a matrix and call it A. So here I have 2, so I'm going to write it here as being 2. I'm going to put this 5 right out here. I'm going to put this 3 right below the 2. I'm going to put the 4 right below the 5. And this would give me a 2 by 2 matrix, right? And this matrix, I'm going to call it A. So this is matrix A here, all right? Now I need a matrix that I'm going to call X, and that's what's going to be the variable. So it's going to be X and Y, all right? So these are the unknown values, or the letter in the given system or simultaneous equation, right? Now this is going to equal to 0, 7. So it's going to be 0 and 7. So that's the first step, right? So you rewrite the given equation in matrix form. So I've done that, right? And it is now in the form AX equal B. Now what you need to do is to multiply both sides of the equation now by A inverse. Now I don't have A inverse, I have A. So that means I need to find A inverse. So I'm going to come over to the side here, and I'm going to find A inverse. So A inverse is going to equal to 1 over the product of the main diagonal, which is 2 times 4. So I'm going to write it here. It's going to be 2 multiplied by 4. And you put that in a bracket. Minus the product of the non-leading diagonal, which is going to be 3 times 5. So I'm going to put that in a bracket. So that's going to be 3 times 5 times the adjoint of the matrix A. In order to obtain the adjoint of A, I must switch position of the leading diagonal. So where 2 is, I'm going to put 4, and where 4 is, I'm going to put 2. So it's going to be 4, and then 2 is going to be down somewhere here. And then, if where 5 is, instead of writing back 5, it's going to be negative 5, and then it's going to be negative 3. So it's going to be negative 5 and negative 3. And all I need to do is to just simplify this. So if I simplify this, it's going to be 1 over 2 times 4, that's going to give me 8, minus 3 times 5, that's going to give me 15, times the adjoint of the matrix, which is 4, negative 5, negative 3, and 2. And this can be simplified to give us 1 over 8 minus 15. That's going to give us negative 7. So I'm going to put the 7 here and put the negative beside the 1. So what I have is just negative 1 over 7. Alright? Times the adjoint. And that's the inverse of A there, which is 4 minus 5. Negative 3 and 2. So this is now A inverse. Alright, so this is A inverse. Now after you find what A inverse is, you're going to take A inverse to multiply both sides of your equation here. Now you must also recall that A inverse times A is going to equal to I. So if I multiply A inverse by A, all that will give me is just the identity matrix, which is I. So instead of writing out all of this, to save time, I'm just going to recall that A inverse times A will equal to I. So I'm going to write this matrix here, which is I. So here, I'm just going to write 1, 0, 0, 1. All right. Times xy. Which is going to equal to A inverse. I'm going to write it for this side now, which is A inverse, which is equal to negative 1 over 7 times the adjoint, which is 4, negative 5, negative 3, 2, times the matrix B, which is just 0, 7 here, which is just 0, 7. Now you must remember that the identity matrix times xy, it functions as 1. So 1 times anything basically gives the back itself. So what we're going to left backward on this side is basically xy. So left backward here is just x, y. Is equal to, I'm going to keep my negative 1 over 7. So I'm going to keep that at negative 1 over 7. And I'm going to multiply out the other two matrix. Right? So how do you multiply matrix? It's row times column. So I'm going to take 4 to multiply 0. So 4 times 0, that's give me 0 plus minus 5 times 7, that's going to give me negative 35. And I'm finished with row 1. So I'm going to take row 2 to multiply column 1 here. So it's going to be negative 3 times 0. That's going to give me 0 plus 2 times 7. That's going to give me 14. So what I left back with now is just x, y, is equal to negative 1 over 7 times, I'm going to simplify what's in this bracket. So 0 plus minus 35, that just leave me with negative 35. And 0 plus 14, that just leave me with 14. And on this side, I still left back with x and y. Is going to equal to, I'm going to take this negative 1 over 7 to multiply each term in the bracket. So negative 1 over 7 times 35. That's just the same thing as saying negative 1 times negative 35. That's going to give you 35 over 7. And 35 over 7 is just 5. And negative 1 over 7 times 14, that's just going to give us negative 2. So therefore, x is equal to 5. And y is equal to negative 2. Alright, so that's how you would do question number 1. Now to example 2, first thing that we're going to do is to rewrite this problem in matrix form. So it's going to be 3, negative 1, 2, 4, and that's what's the coefficient of each term here. So that forms a 2 by 2 matrix. Then we're going to put x and y. Those are the unknowns in the equation that we're solving for, which is equal to the solution, which is 7 and 60. So now we rewrite the problem in the form a x equal b. Now what we need is, our second step is to multiply both sides by the inverse of a. So we need to calculate the inverse of a first. So quickly going to find the inverse of a. So a inverse is going to equal to 1 over the determinant. Alright. And in order to find the determinant, we just simply multiply the main diagonal. So it's going to be 3 times 4. That's going to give us 12. So I'm going to just write it here. Minus the product of the non-leading diagonal. So it's going to be 2 times negative 1. So it's going to be negative 2. Let's put a bracket and put my negative 2. Times the adjoint of A. And to obtain the adjoint of A, you switch the terms in the main diagonal. So where 3 is, I'm going to write 4. And where 4 is, I'm going to write 3. So it's going to be 4, 3. And then you just switch the sign of the other term. So instead of writing negative 1, it's going to become positive 1. And instead of writing positive 2, it's going to be negative 2. Alright, so we can simplify this a little bit. So the inverse of A is basically going to equal to 1 over 12 minus 2. That's just give us 14. So it's going to be 1 over 14 times the adjoint. Alright, and the adjoint is 4, 1, negative 2, 3. Now we're going to use the A inverse to multiply both sides. But remember, A inverse times A, that's what's going to give us the identity matrix of a 2 by 2 matrix. So when we multiply this side by A inverse, all we end up with is just 1, 0, 0, 1. Times xy which is equal to the inverse times b, so it's going to be 1 over 14 times the adjoint, which is 4, 1, negative 2, 3, times matrix B, which is just 7, 16. We're basically going to just multiply out this and we're basically finished. So the identity matrix times xy, let's just leave us with xy. It's equal to, I'm going to keep my scalar quantity here, which is just 1 over 14. And I'm going to just multiply out these matrices. So it's going to be 4 times 7. That's going to give me 28. Plus 1 times 16. That's just going to give me 16. And it's going to be negative 2 times 7. That's going to give me negative 14 plus 3 times 16, and that's going to give me 48. All I need to do is to simplify this. So I still have xy on this side. Going to equal to 1 over 14 if I add 28 plus 16, now 6 plus 8, that's 14. So that's going to be 4. Carry 1. So 1 plus 2, that's 3, plus 1 more, that's going to be 4. There. Negative 14 plus 48 is just the same thing as saying 48 minus 14. So 8 minus 4, that leaves me with 4. And 4 minus 1, that leaves me with 3. So that's just 34. Alright. So all I need to do is to multiply each term here by 1 over 14. So on this side, I'm going to left back with xy. And 1 over 14 times 44, that's going to give me 22 over 7. This is going to give me 22 over 7. And 1 over 14 times 34, that's going to give me 17 over 7. All you need to do at this stage is just write your final answer. So therefore, x is going to equal to 22 over 7, and y is going to equal to 17 over 7. Alright, now to question 3. First thing I'm going to do is to rewrite this question in matrix form. So you're going to take the coefficient of each term. So it's going to be 4, 2, 3, 2. That's going to formulate matrix A. Then it's going to be x, y, which is equal to, which is going to equal to 1, 2, so this is A, X, and B. Now we need to find the inverse of A and take the inverse of A to multiply both sides. So I'm going to work that out here. So A inverse is going to equal to 1 over the determinant. Now it's going to be 4 times 2. So the main diagonal, the product, 4 times 2, that's going to give us 8. So it's going to be 8 minus 3 times 2, that's going to be 6. Alright, times the adjoint of A. The adjoint of A, where 4 is, we're going to put 2. And where 2 is, in the main diagonal, we're going to put 4. I'm going to change the sign of the other term, so it's going to be negative 2 and negative 3. And we can simplify this a bit. So it's going to be 1 over 8 minus 6, and that's going to give us 1 over 2. Alright, so it's going to be a half times the adjoint, which is 2, negative 2, negative 3, 4. Alright, so this is now A inverse. At this stage, you're going to take A inverse to multiply both sides of the equation. Alright, so it's going to be 1 half two, negative 2, negative 3, 4. So it's the inverse times A, which is going to be 4, 2, 3, 2. And it's going to be xy equal the inverse times b, so it's going to be 1 half to negative 2, negative 3, 4 times the matrix B, which is just 1, 2. Now, the inverse of A times A, all that's going to give us is just the identity matrix, which is 1, 0, 0, 1. Then this is going to times xy going to keep our half, and we're going to multiply out the other two matrix. So it's going to be 2 times 1, that's going to give us 2, plus negative 2 times 2, that's going to give us negative 4. You can always put your negative number in a bracket. Then it's going to be negative 3 times 1, that's going to give us minus 3, plus 4 times 2, that's going to give us 8. Now the identity matrix times xy, that leaves us with those x, y. It's going to equal to 1 half, and we'll just simplify this here. So it's going to be 2 plus negative 4, that's just going to leave us with negative 2. And then it's going to be minus 3 plus 8, that's going to leave us with positive 5. All you need to do is to take this half to multiply each term. So it's going to be xy here. Is equal to a half times negative 2, that's also going to give us negative 1, and a half times 5, that's also going to give us 5 over 2. So final answer is going to be x equal -1 and y equal 5/2. And that's it. Thank you for watching, and I hope you have enjoyed this video. Please remember to like, subscribe, and share. Thank you.